A basic Colab account is sufficient. Okay. Hello, everyone. Welcome to the Python tutorial. This is the link to the tutorial, which you should already have received. But here it is anyway in the chat. My name is Andreas. I have been writing Python for about 8 years on and off, other kinds of programming languages before that. And I've been part of committees where we actually design the programming languages. And it's just one thing I learned in all this time. It is that learning a programming language from a 1-hour tutorial with just me talking is a terrible way to learn. Instead, it's much better if you learn by actually like getting your hands dirty, as they say, and trying out for yourself. And so in the past years, it has been me talking or somebody else for 1 hour and then a tutorial of half an hour. We're going to flip that around. I'm going to make it much shorter, and then you'll have a lot more time for the actual assignment. And then when you have any questions, you can type them in the chat. I will say your name, and then you can unmute yourself, and then we can talk about it. And I think that's going to be much more productive for your learning efforts. Because rarely is it so that everything just works perfectly as it usually does in sort of a practice tutorial setting. Okay, so this is the Python tutorial. You are kind of already expected to know Python for this course. It is a requirement. And so by that, we mean the basic section here. Possibly many of you will be familiar with NumPy as well, but we'll get to that. And then there's Pandas and Plotnine. These you're not expected to be familiar with. Plotnine is just for plotting. Pandas is for tables. But there's not too much content here. Let me just check that everybody's muted. All right. There's not too much content here. You can probably learn that pretty quickly. So in my case, in about 2013, I also took a machine learning course, and I did not know Python, but I knew other kinds of programming languages. And so if that is your situation, you will probably be fine. However, you should expect to put in more hours. And so a good way to start is the official documentation for Python, which you'll find at docs.python.org/free. Not .free, just /free. And there you'll find the official tutorial. And so this is going to be much more comprehensive than what I could do. But I would say just from 1 to 5, that should be sufficient from this course. There might be a couple of things in chapter 9 and chapter 10 that might be useful, like the sections on mathematics. However, generally just 1 to 5 inclusive, that's should be enough. So if you don't have any experience with programming, then you really should reconsider this course. All right. We'll be doing Python in Google Colab. Somebody asked if you need the pro account. No, you do not need the pro account. Just the basic free account is perfectly fine. You access Colab by going to colab.research.google.com. In this case, you can just use the link I sent. I'll take you directly to the assignment. And there's a couple of things about this. So one of the reasons why we expect you to use Google Colab is that each of you might have your own individual setup if you're running locally. You might have different Python versions, different operating systems, different installations of Python. There's different ways to install that. You might have different versions of the modules that we require, NumPy, Pandas, and Plotnine. We'll require some others later. And that's just way too much for us to debug. All of those individual setups. That's like 130 students for this course. And so instead, if we just all run in Google Colab, then you will all run in exactly the same environment, and you won't have to set up anything in order to run Python locally. That's going to be much easier for everybody. Okay, so Google Colab is a notebook setting. I'm just gonna mute my professor here. Okay, so Google Colab is a notebook setting. So what that means is that it's kind of like a mix of text, outputs, and code. So we can set a equal to 1. That would be our code here. It just takes a bit of time to connect. Okay, and then we could print this like this. And I mean, this is all what you should already know, regardless of your program language. But then you can increment this, and I should be typing A here, and we can print that again, like so. And so you can kind of see that there's this mix of code and output, and we can also add text by pressing the text button there, and then we can make a title, for example, like so. The tricky thing here is that because this is all run in what's called the same Python session, if you run one of these cells here again, for example, the A plus 4, and then print out A, then you'll get 9. Which doesn't really make sense if you're reading this top to bottom as a Python script, but it happens because, well, A was already 5, and so now we're adding 9. And that kind of adds, so we're adding 4, and now we get the 9. And that's a little tricky sometimes because you need to keep in mind not what the code is, but also what your state is, like what are all the variables assigned for. And that's way too much sometimes. And so if you run into issues, the good thing to do would be to press the restart and run all. Okay, and so what that will do is it will give you a fresh session of Python where nothing has been run, and then it'll run everything from top to bottom. Now we get the results that we expect. So if you run into issues, that should be like one of the first things on your checklist. Just make sure you do that. The other thing on your checklist should be, am I running in Google Colab and not my local environment? Yes. Okay, so we're not going to go into too much detail with the basics. As I showed you, you can look at the tutorial. So to talk about NumPy, let's make a title here, NumPy. You can import this as import NumPy as NP. As NP is just by convention that just assigns the module to the variable NP. And then we can create an array like this. Print. Okay, and so this is different from a list if you just done this, although it looks very similar, because what we can do is we can, for example, add 2 to this. And so that will add 2 to every single element. And so what NumPy is essentially is it's a framework for you to deal with numerical calculations on arrays. Arrays do not have to just be lists. They can also have several dimensions, like this one. So that has 2 dimensions that we'll usually call a matrix in mathematics. And the one here would be a column vector, although it's printed as a row. Okay. And so really there's not that much you can do in NumPy that you couldn't already do with for loops. However, you will use much less code and it's going to run much faster. And because in machine learning, we will use a lot of calculations with numbers, having fast computations is important. Okay, the second part of this will be Pandas, which is by convention denoted as PD. And what Pandas is just a way for you to create tables. And so we can actually, each column here is essentially a NumPy array. We can create a column that could be the digits, and then we can say words. Let's do this. And then we have 1, 2, 3, 4. And so that will create a table for us. And we can assign that to a data frame, and then you can just type this to print it out. And you will not have too much use for this because it's not like we deal a lot with these kind of very well-defined table structures. Instead, we'll typically convert them to, for example, matrices, and then you'll just operate with them as they were just one big NumPy array. However, sometimes you will import data, or sometimes with tables in, for example, a CSV format, or sometimes you will have outputs which are best organized as tables. Okay. Yeah, and so in particular, you might have, for example, for each different model, for each different data set, you have different kinds of, for example, the performance of that model for that data set. And so a good way to organize those results would be, for example, as a table like this. The second use of this is for plotting. So, it's not MP, that's P9. And then we just need to run this. So you can, in this course, I believe, do plotting in any kind of framework that you like. However, we do need your plots to be legible. So that means you need to have the right tick marks on the X and Y axes. You need to have the right labels on the X and Y axes. You need to have the right legends, and this shouldn't overlap your curves. You need to have the domains of your axes. They should also be the same, so you can compare different graphs more easily. And this kind of becomes a lot, but what Plotnine does is it kind of takes care of all of these things for you. Okay, so you create a plot by doing ggplot. Gg means graphical grammar. So there's been books written about making plots in this way. And then we can define the aesthetics. So for example, the x-axis, we might want to be the word. The y-axis, we might want to be the digit. And so that kind of defines the aesthetics of our plots. And then we can then specify how we want that plot to be rendered. We want it to be lines, we want it to be points, do we want it to be bars? So you can, or columns as they call it here. P9 is not defined. Right. Okay, there we go. And so now you'll see that we have a decent looking plot with the right tick marks and the right labels. You can even do something like fill, digit, and then we now have also colors in this, or you can, and we get the right legend as well. Or you can set the words, and then we get discrete legends because that is a discrete column. And so my opinion is just that this is a lot easier than having to write out like individual commands for setting the labels, tick marks, legends, colors, etc., and trying to synchronize all that. If you are familiar with MATLAB or Matplotlib, then you all have been familiar with plotting in this way, and is quite a pain. If you wanted something else than, for example, bars here, let's say you wanted points, it's just a single point, then you could get this. Now you'll see that the border here is black, so we can set the border color with color. And so now we get something similar to this, and you can also do geom line, although that will not work right now because our x-axis is discrete. Okay, so you can learn about this in the tutorial. The first thing you might want to do is just press the run all. And so that will just set everything up for you and create all the outputs. The basic and NumPy sections are from past year and quite brief, and then I have written the Pandas and Plotnine section for this year. For chapter 5 here, you have individual problems, and these are all optional. You don't have to do any of this. So do them in the order that you feel you'll be most productive. But just to demonstrate here we have problem 1, where we have to determine if a list is monotonically increasing or decreasing. So monotonically increasing might look like this, for example. And well, that's enough for now. And so we might want to check if the data 0 is less than data 1. And then if that's true, then we could just return this. So that is not the solution to this question, but that might be a good start. And then you can check your results or your implementation by running this command here. And then you're gonna run through all the tests, and so you see we are actually passing the first test here, but we're not passing the second test here because that's a monotonically decreasing list with 2 elements, and we don't support that. Good. So what's gonna happen now is that you're gonna go to this notebook. I'll just parse this link again for those who are late. And you just work through this on your own pace, and then I will be here until 10:30 p.m. Oh, sorry, a.m. Not that long. What you can then do is you can write your question in the chat, just very briefly, and then I will get to your name. I will read out your name and your question, and then you can unmute yourself, and then we can have a conversation about it. Okay. Just me providing straight answers to you is often not the best way to learn. Good luck. Have fun. Feel free to unmute yourself now as well. GLHF, yes.
Guck mal, Land.
Hello, Miriam. You want to discuss the issue? When can we use OR when XOR? Okay. So XOR, if both variables are true or both inputs are true, then you get false, right? Where with OR, if both are true, then you still get true. You should feel very free to talk if you have more questions regarding this. Okay. I mean, you're unmuted, so you can talk. If you do not have a microphone, then you can type in the chat. Shanwayne, do you want to unmute?
Yes, can you hear me?
I can hear you, yes. Excellent. We can have an interaction. Okay, so I don't think there's any particular difference between those. The only difference is that with the dictionary, you can, and with the get method, you can set a default, right? So if we have a dictionary that's, I don't know, fish one, and then you want to get maybe a different kind of animal, like an ant, right? Then you can set a default value in the second argument. Where with this, I mean, you still just get nothing, the none, right? I think also with the, if it doesn't exist and you do d and, then you get an error. So those are the differences. It's mostly if it does not exist, there's a difference.
Okay, thanks.
No problem. Okay, and this is the table for the XOR. But since there's 20 minutes left, maybe you can type in the chat how far you are, and if you have any difficulties. It's also a reminder that you don't have to do things in order. Everything here is completely optional. The best way to ask questions after the class would be on Piazza. If you have questions to any of the problems in this assignment, probably others will have as well. And so by asking on Piazza, then everybody can read the answers. Lamia,
Yes, actually it's good. It just I thought it wasn't like it didn't pass the test because I printed in my function, and when you print it makes an error, but it's a good.
Yeah, I think it is good. Great job. Great job. Nunjia. That's yours.
Hi.
Hi. So close. You want to talk? So you think welcome to use Seaborn if you prefer this. I think Plotnine, it's more for like converting a data frame into a plot, and then you get what's called this graphical grammar, where you can kind of compose your plot, right? So if, for example, you both want points and lines, then you would just write both of those commands. So you're kind of like always adding something.
Okay.
Where with the Seaborn, you kind of have to define all your plot, or you have to like find a specific command to create the exact plot that you want.
Okay. Okay, so there's more like freedom here in Plotnine, maybe?
It adds freedom somewhere and it subtracts other places. Yeah.
Okay.
I think, for example, if you want 3D plots and contour plots, then Seaborn is probably easier to use.
Okay.
Also, like ggplot will enforce some like good plot stylings that you might not have the flexibility to avoid. Like if, like for example, if you want only some of the subplots to have the same axis, but some others shouldn't, then you can't really do that in Plotnine because you're not supposed to make plots like that.
Got it. Okay. Thank you.
No problem. I am not sure when the TA hours are. That is a question for Sarath. I think they're still being scheduled. You can reach me now via the Piazza platform after the class. Hello. So the class is now over. I really hope you learned something. It's always hard to tell when there's so little interaction. But feel free to ask questions on Piazza, and I'm sure Sarath will announce the TA office hours soon, and then maybe we can talk there. Yeah, have fun, good luck, and I hope you learned something.
Goodbye.
Goodbye.